Okay, let's discuss some counting principles. Let's suppose you're in the market for a new car. You want to get a new car, and you have two options. You could get a sedan or you could get a coupe. 4-door or a 2-door. So let's write that down. You could get a sedan, you could get a coupe. Excuse me. Also, the car dealer tells you, we'll just keep this simple. You could have 3 different colors. You could have white, black, or red. We'll just stick with those 3. So you could have a white sedan, you could have a black sedan, you could have a red sedan. You could also have a white coupe, a black coupe, or a red coupe. Now, when you look at that and you see what your options really are, you'll realize there are 6 different things you could have. I mean, that was pretty obvious, and the numbers were relatively small, so we can deal with that. There's a shortcut. We're going to use this simple example to find the shortcut, and here it is. There were 2 different types of cars I could have gotten in terms of the number of doors. I could have gotten a sedan or a coupe. 2 options. There were 3 different options here. I knew the answer was 6. What can I do to a 2 and a 3 to get a 6? I think I got this. We'll multiply them. So here it is. For the next several problems, what we're going to do is find out how many options we have and then multiply those options together. So here goes. Example 1. Let's suppose you wanted to know, for some odd reason, how many different types of license plates can be made in North Carolina using the standard way of doing it. So there are, in North Carolina, 3 letters, we'll put 3 blanks, followed by 4 numbers. 2, 3, 4. And we're going to find out what our options are, and then we're going to multiply them. Just for the sake of it, I'm going to put letter here. This one's a letter. This one's a letter. This one's a number. That's not a hashtag. These are all numbers. They're all single digits. Okay. We have 26 letters to choose from. In case you never took the time to count the letters in the alphabet, there are 26 of them. So we have 26 options right here for the first letter of your license plate. Anything from A to Z. Now, when we go to the second letter, we have, 26 options. We still have the same letters to pick from. We're going to multiply these. When we get to the third letter, we have, you guess it, 26 options. Okay, when we get to the number, we need to pick a digit between 0 and 9. And when you count those carefully, and you can figure this out, you're smart, there are 10 digits. From 0 to 9, that's 10 digits. So you have 10 options right here. We'll stop right here and say something. You could make the argument that the first digit is never 0, but in that case it still creates a specific number. For example, and this is slightly irrelevant to the problem, but for the sake of argument, one of you might have been thinking this. For example, if your license plate is number, and then it's like 963. That's obviously not a 4-digit number, but technically there's a 0 right here. Just say it. So 0 is an option for your first one. Same goes for 2-digit or 1-digit numbers. Well, those are very rare to find on license plates. Okay, so you have 10 options here. When you come to this one, you have 10 options. Anything from 0 to 9. And again, 10 options. And again, 10 options. We're going to multiply all of these. You see why it's easy to have a shortcut as opposed to what we did with the car thing. I could list them all when there were cars. There's no way I can list all of these. Already, this is up in the millions and millions and millions. Okay, we're going to multiply all those. Before you type that in your calculator, let me remind you of some simple math you learned in the 5th grade. We have 3 26s. We have 4 10s. It's equal to that, whatever that is. So we'll type that in our calculator, and we'll find it. 26 to the 3rd, 10 to the 4th. That's a very large number. 175,760,000. 0, 0, 0. It ends with so many zeros because 10 to the 4th is 10,000. Okay, there was example 1. We'll give you just a second to soak that in, make sure you understand where it came from. We're going to move on to example 2 in about 10 seconds. Since example 2 is the same idea, we're going to keep the same format. We'll erase everything else though. But let's suppose that the Department of Motor Vehicles in North Carolina says that you cannot repeat a letter on a license plate. For example, your license plate couldn't be STT. You couldn't repeat a T. You couldn't have ABA. You can't repeat that A. All right. Okay, so here's the deal. Our first option for a letter, we have 26 things to choose from. So there are 26 letters that are available to choose from. We just chose a letter. Doesn't matter what we chose, but we chose a letter. And now we have one less option. We now have 25 options. For example, if we chose an A for this first letter, we only have B through Z now. There are only 25 options. Now we've used 2 different letters, and now for our third choice, we only have 24 as an option. Again, we're going to multiply all of these. Now it said you can't repeat a letter. You can repeat a number. We're going to make the assumption that you can repeat a number. So I have 10 digits I can choose from here, 10 here, 10 here, and 10 here. And we'll figure out what this is. I can't use exponents with this part. So I still have 26 times 25 times 24 times 10 to the 4th, which again is 10,000. We'll type that in our calculators. I'll give you a minute to do that. Awkward looking comma, but there it is. 156 million is what I got. Yep, that's correct. Okay, take a second and look over that while I begin to erase it. Okay, example 3. Example 3 goes back to the original type of example, and that's the one where you were buying a car. Okay, so you're going to get some ice cream, and you have several different options, and this one should be pretty straightforward, and I think you can figure this one out relatively well, but you're ordering ice cream, and you can get a cup or a cone. So what you put your ice cream in, you have 2 options. So here we go. So this is going to be the container for your ice cream. The container for your ice cream. And we have 2 options. And then you have 3 different flavors. You have chocolate, vanilla, or strawberry. I recommend the chocolate or the strawberry, but you do whatever you want. So these are your flavors. And there are 3 of those. And then you could get different toppings. You could get sprinkles, walnuts, or chocolate syrup. Now you can only get one of each of these things. So sometimes they won't specifically give you the numbers. You kind of have to count, but you're seniors and juniors, you can count. This is not going to be that hard. I believe you know where to go from here. Bless your heart if you don't. 2 times 3 times 3. You don't even need me to give you an answer. I'm not going to tell you what it is. I believe you got this. That leads us to our first definition. And the first definition is the fundamental counting principle. And it says so on your paper. I'm going to abbreviate it, fundamental counting principle. Let me give you as precise a definition as I believe is necessary for this. And this is going to be when events occur in order, then we should multiply number of options for each event. Now you'll notice I skipped example 4. Not going to lie, it was an accident, but that's okay. It'll work to our advantage. We're going to go back and hit example 4 because example 4 starts getting into the next thing. So it's okay that I went ahead and gave you this definition. Sorry about that. Okay. Fundamental counting principles: when events occur in order, we need to multiply the number of options for each event. 2 different types of cars, 3 different colors, 2 times 3. 2 different ways of holding my ice cream, 3 flavors, 3 toppings, 2 times 3 times 3. Again, I'm not going to tell you what it is. You can figure it out. You're smart. Okay, let's get to example 4. We have 5 people that are going to run a race, and they're Antoine, Bernie, Carl, Dennis, and Herbert. Now, I did that intentionally, so we would have pretty much consecutive letters. Antoine, Bernie, Carl, Dennis, and this other guy right here that didn't know the next letter of the alphabet, and it's H. So we have A, B, C, D, and H, and they're all running in a race, and we want to know in how many different possible ways could this race turn out. Let's draw some blanks. Literally, not figuratively. So we're going to have a first place winner. We're going to have a second place, which would be the first loser. We're going to have third place, we're going to have fourth place, and we're going to have some poor guy that comes in fifth place. Okay, so the question is, how many options do we have for first place? When this race starts, how many different people could possibly come in first? How many people are in the race? There's 5 of them. So there are 5 different people that could be in first place. It doesn't matter who it is, but we just got a first place winner. So since we just got a first place winner, we now have to stop and ask ourselves and think, how many possible second place winners are there? Let's just hypothetically say that H here, Herbert, came in first. This is an easy question. You got this. If Herbert's gone, how many fourth place winners are there? There you go. And I know you know what I'm about to write. Right there. You may as well go ahead and put them in all of these. There we go. We're going to multiply these. You can see the pattern. If we have somebody came in first and somebody that came in second, and now we have how many people left in the race? There's only 3 of them. And then, if we have 3 people that are out of the race, there are only 2 left. And then there's 1 person left. Basically, we just counted backwards from 5, and we're multiplying everything. There is a shortcut for this in your calculator. In the meantime, though, you can type this in, and you get 120. There are 120 ways that 5 people can finish a race. It's going to lead us to our next definition, which is right below the other definition, and it's factorial notation. Now, factorial itself, not necessarily a notation, but the factorial itself is the product of all the positive integers less than or equal to a given number. The product of all of the positive meaning obviously greater than 0, integers, obviously no fractions, no decimals, less than or equal to a given number. Okay, let's kind of tie this in with what we just did. How many people were in our race? 5. We're going to multiply every number less than or equal to 5 together, all the way till we get to 0, but not counting 0. So 5, 4, 3, 2, 1. If we would have had 8 people in our race, we would have done 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. We're going all the way down to 1. Okay, now the notation itself is going to look like this. You can go back up to example 4 if you like, and you can put this. It looks like punctuation, and it is kind of exciting when you see it. This is the way it's written. It's an exclamation mark. So it's kind of like 5! So we have 5 factorial. And that means 5 times 4 times 3 times 2 times 1. So now we can go on down to the very next problem. And that would be example number 5. And it says, in how many orders can 6 people finish a race? Well, there's a long way of doing it, and there's a short way of doing it. I'm about to show you the shortcut in the calculator. So, example 5. So here we go. Example 5. And basically there are 6 people in a race. And race, and then race, if I could spell, that'd be great. 6 people in a race, and we want to know in how many different orders can they all finish. And that's going to become important when we get to the back side of the sheet. How many different orders can all of them finish? Let's see. We have 6 people in a race. The long way of writing it is 6 times 5 times 4 times 3 times 2 times 1. Ain't nobody got time for that. So here it goes. 6 factorial. Nobody wants to type all that either. Here it is. Grab your calculator. All the special little math tricks we're going to do on our calculator in this section are going to be under the math menu, and it's also going to be under PRB. So here you go. You got your calculator. Press a 6. Go to math. Go over to PRB. That means probability. And hit the exclamation mark. 720. There you go. There are 720 ways we can do this. Okay. That does not bring us to the end of this lesson, but it kind of brings us to the end of this idea. So I'm going to stop the video here, just so we can kind of have a break in it, just in case you have gotten to a certain point, the bell's about to ring, and you can resume with the other video. If you have time, go ahead and go to the other video. Please do not stop. Keep on going if you have time.